For decades, software development depended on engineers manually tending code like farmers. Today, that manual labor is being replaced by an automated harvester. In the traditional red teaming process, human researchers act as hackers. They poke and prod an AI model, looking for any vulnerability or unintended behavior that could be exploited. But we have reached a saturation point. The latest models are now capable of passing nearly every security test and jailbreak attempt a human researcher can devise. This creates a massive drag on development. When humans manually discover a bug, write a report, and wait for a patch, the entire cycle of improvement slows down. To bypass this, frontier labs are building specialized models whose only function is to attack and stress test their primary systems at a scale no human team could match. When an AI model can autonomously identify its own flaws and immediately implement patches, it moves beyond simple testing. It begins the process of improving its own internal structure, initiating a cycle of self-correction that functions without human oversight. OpenAI's GPT-Red is an example of this new class of model. It is a dedicated adversary, trained specifically to find the cracks in other AI systems. This setup uses self-play, a technique where a system masters a task by competing against itself. It's the same logic that allowed AI to surpass human experts in the game of Go. In this environment, GPT-Red receives a reward signal every time it breaches the target's defenses. This incentive drives it to find even the most obscure vulnerabilities. Simultaneously, the defender model learns to block the exploit. This pressure forces the attacker to invent increasingly complex and creative methods to succeed, escalating the sophistication of both models. This bar chart shows the result of that escalation. In head-to-head testing, the automated attacker found successful exploits in 84% of scenarios, while human researchers only managed 13%. By automating this loop, labs can generate security refinements and training data in a single afternoon that would otherwise take human researchers months to document. While the software loops are fast, they are tethered to the physical world. Running these recursive cycles continuously requires a massive amount of electricity and silicon. This explains why Anthropic has recently hired neobank CEOs and supply chain experts, people whose expertise lies in high-stakes logistics rather than traditional AI research. Their job is to manage the energy demands and hardware efficiency of these clusters. They are solving a physical problem: how to keep the servers powered as the software demands grow. This illustrates the second half of the chessboard. In exponential growth, the early stages appear manageable because the numbers stay small relative to our perception. Once you cross the midpoint, the doubling effect results in numbers so large they dwarf everything that came before. Crossing into this second half means a slight lead in data center construction or power acquisition can create a gap that competitors struggle to close, simply because of the literal physical scale required to keep pace. As these models continue to provide flawless code and security fixes, they create a psychological trap for the people building them. Every success provides positive reinforcement to the engineer. Over time, this creates a conditioning effect. Humans begin to rely on the model's track record, checking the work less rigorously because the output has been consistently correct for so long. We are approaching a scenario where a model suggests a change to its own architecture that is too complex for a person to verify. Based on that established history of success, the human engineer is likely to approve the change anyway, effectively moving the core logic of the model into a black box. This shift toward autonomous development is why leaders like Demis Hassabis are raising concerns about the speed of these cycles. They are calling for oversight structures similar to financial regulators like FINRA, bodies that can monitor the system even when the underlying logic becomes too dense for manual review. The intelligence flywheel is now driven by computation speed and the availability of grid power. Humanity initiated the process, but the controls are increasingly moving beyond our direct oversight.